Good evening, the executives. Now, in this case of this kind of question, how do we solve it? The ground state of hydrogen may be represented by the energy minus 13.6 electron volts and fixed excited state by minus 3.4 electron volts. The scale in which an electron is completely free of the atom is zero energy. Calculate the wavelength of radiation. Planck's constant is equals 6.6 times 10 raised to power minus 34 joule seconds. 1 electron volt is equals to 1.6 times 10 raised to power minus 19 joules. Now, in this case, before I solve, I will explain some terminology, some things for us to know. In an atom, electrons are tend to teleport from one level to the other. Now, there are levels in the structure of an atom. Each levels has its energy, and each levels energy are greater than the other. Now, let's assume this is the nucleus in this case, and this shell or orbital or level is closer to the nucleus. Now, this is telling us that the force of this nucleus holding this shell or orbital is greater than the force holding this. So electrons in this case, with the bombardment of energy, electron in this level can jump to this level. Now, the electrons here is not very easy to remove, so it requires more energy because it is held closely and very tight to the nucleus. Now, this energy that holds this next electron on this shell from the nucleus is very weak because it's far to that area. Now, this electron can teleport to the next shell or level, while this electron, the one present here, can also teleport. Once this teleports, there's no longer shell around it, then it's going to be free away. That's when this is telling us that completely free of the atom is zero energy. So to remove this last electron, there's going to be a difference in energy. So the energy for this to jump from here to here. So how do we get the energy? There is a law that states that the energy carried by a quantum of radiation is directly proportional to its frequency. So the energy carried by a quantum of radiation is directly proportional to its frequency. Then E is going to be equals to, by bringing a Planck's constant in, that's going to be hf. Now, this energy is the energy difference between the first level and the second level, where the electron rather has jumped. So that would be the E we're using here is going to be equals to the E. Let's assume the E naught minus the E2. That is the energy of the level at which it was, and minus the energy of the level where it's teleporting to. So for us to get the energy to be used here, now let's calculate the frequency. We're told that it teleports from minus 3.4 electron volts to this, and energy as a unit to be in joules. So we're gonna convert minus 3.4 to joules. 1 electron volt equals to this. So in order for us to get a joule carried by a quantum of radiation, which is directly proportional to its frequency, now we have to subtract. We have to find the difference as a change. That is change in the energy. So we have to find the difference. So the difference between the orbital where the electron is jumping from to the orbital or the level where it's jumping to. So where it's coming from, said it earlier that it has a greater energy, which is having minus 3.4 electron volts, minus 3.4 electron volts, minus we're going to subtract it from the second where it's jumping to, which is minus 7.6 electron volts, minus 13.6 electron volts. So after subtracting, then, which means definitely we have definitely found a change in energy, which is, finally we're gonna say minus the 3.4 electron volts plus 13.6 electron volts. Definitely wanna have this. Now I have minus 3.4 plus 13.6, which is equals 10.2. So we have 2b equals 10.2 2 electron volt. So since 1 electron volt is equals to 1.6 times 10 raised to power minus 19, then we'll take it this way. 10.2 electron volt will be equals the energy, which is joules. So because x joules, so you cross multiply, we get our answer to be x joules. It's gonna be equals 10.2 times 1.6 times 10 raised to power minus 19. So take this way. So I've got something for 10.2 multiplied by 1.6, which is giving us 13.32. That's 16.32. 16.32 times 10 raised to power minus 19 joules. Now after getting our energy, now asked to, from the question, we're asked to calculate the wavelength. Now there's a formula that says that our velocity is equals to f, that's the frequency lambda. Then according to that, we have energy equals f hf, rather Planck's constant, then multiplied by the frequency. We're looking for the wavelength. Then we're gonna get our frequency here. We're gonna place it here that make wavelengths of the formula. So therefore our wavelength here is gonna be equals to v over f. Then what's f? So find f here. F is gonna be equals to, therefore, energy over Planck's constant. The f equals energy 16 rather 0.32 times 10 raised to power minus 19 all over, then all over Planck's constant, which Planck's constant is 6.6 times 10 raised to power minus 34 joules seconds. 6.6 times 10 raised to power minus 34. 6.6 times 10 raised to power minus 34 joules seconds. So dividing this, what we're gonna have, then divided by 6.6 equals, we have f is gonna be equals, so dividing this, we're gonna have this value. So we have the value that will be 2.472 times 10 raised to power minus 19 minus 34. So finally we have 2.47 times 10 raised to power, then minus 19 plus 34. It's gonna have minus 19 plus 34, and minus 19, it has to be sure, then plus 34. That gives 15 raised to power 15 adds. So once we get that, then you replace that in this. So our lambda equals lambda in meter, and lambda is finally equals the velocity of light, 3.0 times 10 raised to power 8 meter per second over 2.47 times 10 raised to power 15. So 3 divided by 2.47, 3 divided by 2.47 equals, then we have here 1.215 approximately times 10 raised to power 8 minus 15. Then we have approximately has to be 1.215 times 10 raised to power minus 7 meters, and that's our answer. So it takes the wavelength 1.215 times 10 raised to power minus 7. The question asks that you calculate the wavelength of the radiation. So the wavelength of the radiation is 1.215 times 10 raised to power minus 7. Thanks for watching. Kindly subscribe to our YouTube channel.